Hello everyone, welcome to my channel One Concept W. This is one of the DC series motor question. Let's solve this question. Here it is given it is a 15 kilowatt DC series motor. Means output power is 15 kilowatt and the terminal voltage is 230 volts. It is drawing an current of 80 amps and running at a speed of 1000 rpm. It has the following losses expressed as percentage of motor input. The given armature ohmic losses is 2.8% of input power. Similarly, field ohmic losses is 2.6% of input power. Rotation loss is 2.2% of input power. Already they are asking to neglect the armature reaction and magnetic saturation. Assume rotation losses remain constant. Under any load, rotation loss is constant. P rotational losses is constant. If suppose a motor draws half of its rated current and at rated terminal voltage, what will be the speed in RPM? What will the shaft power output? Let's solve this question. Let's write down the data here. Given it is in DC series motor and terminal voltage at 230 volts and speed of 1000 rpm and it is drawing an armature current of 80 amps. The input power is Vt into IL. Here IL is in 80 amps. In series motor, load current equal to armature current. Then the input power is Vt into IL. Vt is 230 and armature current of 80 amps. Then the input power is 18400 watts. Now bifurcate the losses. They given the armature circuit ohmic losses is 2.8% of input power. Here I already calculated the input power. Now I am calculating the armature ohmic losses. Is 2.8% of input power. I got armature ohmic losses of 515 watts. After calculating armature ohmic losses is nothing but an Ia square into Ra equal to 515.2 volts. We already know armature current is 80 amps. We can able to find armature resistance. By substituting the data here, I found armature resistance of 0.0805 ohms. Similarly, the field ohmic losses is 2.6% of input power. Field ohmic loss is 2.6% of input power. Input power already 18,400 watts. By this, the field ohmic loss is 478.4 watts. By this, I can able to find field winding resistance. We already know in series motor, series field winding and armature winding is connected in series. By this I can able to find field winding resistance. The field winding resistance is 0.0746 ohm and rotation losses is 2.2% of input power. By this the rotational losses is 404.8 watts. Already they given the rotation loss is kept remains constant under any load. They given rotation losses remain constant. Means under any load the rotation losses will remain constant. Now I need to find the speed of the machine when operating at half of its rated current. Let's calculate that particular question. Here in the case 1, let's find back EMF under full load condition. Back EMF EB under full load condition equal to Vt minus Ia into Ra plus Rc. Under full load condition, the armature current is 80 amps and terminal voltage at 230 volts. Armature resistance and field line resistance we calculated above. By this, I can able to find the back EMF is 217.6 volts. Now under half load condition. Under half load condition, the load current will reduce by half. Then the armature current will become 40 amps. Now I am calculating back EMF under half load condition. EVT equal to Vt minus Ia into Ra plus Rc. By substituting armature resistance and field winding resistance and armature current and terminal voltage, I found back EMF of 223.79 volts at half load condition. We already know back EMF formula E equal to K into phi into omega. Here, flux is directly proportional to field current. In series motor, IA equal to IF, then flux is directly proportional to armature current. EB1, back EMF of the motor operating at full load condition. EB2, back EMF of the motor operating at half load condition. IF1, field current under full load condition. IF2, field current under half load condition. N1, speed of the motor in full load. N2, speed of the motor in half load condition. By substituting the above values, I found the speed of the motor under half load condition, half load or half rated condition. The speed is 2055 r. Means we calculated the speed of the motor under half load condition. This one is solved here. They are asking to find shaft power output. Let's before calculating shaft power output, let's calculate what is internal power developed. Internal power developed is nothing but an EB2 into IA2. EB2 we calculated earlier. EB2 we calculated earlier. EB2 is back EMF of the motor under half load condition. It is 223.79 volts. 223.79 volts into armature current. Armature current is 40 amps. The internal power developed is 8951 watts. We already know the shaft power is nothing but an internal power developed minus rotational losses. They already mentioned rotational losses kept constant under any load. Under any load means under full load or half load, the P rotational losses are constant. Earlier we found the P rotational losses. P rotational losses here is 404.88 watts. By subtracting this P rotational losses from P internal, we can able to find shaft power. Here the shaft power is P internal minus P rotational. By substituting the values here, I found the shaft power is 8546 watts. This is this question is based on mainly bifurcating the losses. In order to solve this sort of questions, please subscribe to my channel.